This lab is on the thermodynamics of the dissolution of urea. In part 1, we find the standard change in enthalpy for the process of dissolving urea in water.
Hi, today we're going to be doing a lab. It's the last lab of the semester. It's on thermodynamics, which we've been doing in class. And this is called the thermodynamics of the dissolution of urea. And as you should know, dissolution means dissolving. So what we're going to be doing is taking a pre-weighed sample of urea, which is in this weigh boat, and we are going to be dissolving it in 50 milliliters of water, which I've also measured out into a graduated cylinder. And so what we're going to do is we're going to pour the water into a styrofoam cup, as you see here. And the styrofoam cup has a temperature probe in it, and we're going to measure the temperature of the water for a while. Actually, we're doing that already on the graph. So as you can see, we've been measuring the temperature is just a little above 20, 21.2 is what it is now. But we haven't even put the water in yet. So we're going to put the water in first. In fact, I'm just going to go ahead and do that and get this thing stirring. So I've turned on the stirrer now. Let me get a shot of that.
And we're using wireless probes.
Yeah. And this is what the graph looks like. So it's, yeah, the water was about the same temperature as the room, 21.0 clearly. So what we're going to do is wait until we get it, well, we do pretty much have a nice constant value of the initial temperature. I'm just going to move this graph down a little bit. Oh, actually, just going to leave it right there. I'm going to scrunch this down a little. And then I'm going to add all of this urea all at once. And if you're keeping your data sheet, you should write down what was written on this piece of paper over here. 4.863 grams of urea and 50.0 milliliters of distilled water. So I'm going to add this urea all at once, and we're going to monitor what happens to the temperature. This thing is stirring like crazy. Okay, so what's happening to the temperature? You can see clearly. Oops. Just trying to blow up the scale a little bit here.
Now, this is the great advantage to having a computer-generated graph, in that you can change the scale as you need to see.
You can see from that little bump here, that was when I put the water in. So when I want to get my initial reading, you can see here if I blow it up. Hold on, I'm going to get it back. There's a little bump right there. We don't want that. We want this to be the initial temperature. So I'm going to move this over here, and we're just going to use those points. I'm going to start blowing this up a little so you can see that the temperature has gone down, and it's starting to sort of level off somewhat. Let's leave it going for a while and see what it looks like. So here we are, and now we're at about 1100 seconds. That's quite a few minutes, 1100 seconds, because 600 seconds is 10 minutes. So it's been almost 20 minutes since the beginning of this experiment, okay? So what I need to do is I need to get the initial temperature. So what I'm going to do is take the average of these points over here at the beginning of the graph. And the way I'm going to do that is I'm going to use this as the select tool here, the highlight tool. And I have a box, which I'm going to change the size of this box. And then I'm going to hold it over, if I can move it. I'm going to hold it over the graph at the initial points. All right, so is that box pretty good then? It's centered sort of on these initial points, and then I hit this key. the sigma key. And it tells me that the mean temperature there is 21.0. So I'm going to make a text box, I hope, and I'm going to write initial temperature let me get that. I don't know how to spell today. And that initial temperature is going to be 21.0. I'm just going to put a capital C. Okay? And that's 21.0. All right? And it's not really pointing to the right place. I'm going to have it point to here. Okay, hi. So, in order to get the final temperature, I already explained, I believe, how to get the initial temperature. I took an average of a bunch of points over here, and that was 21.0. Now I want to get the final temperature. But the technical thing that we do is we know the temperature went down. So we take the temperature here, here, here. We don't know where to take it from the edge of that curve. And you can see the temperature is also going up as it re-equilibrates to room temperature. So what we do is we select a bunch of points at the end of this line and we extrapolate it back. And we call the mixing time the halfway, when it's halfway down. And so what I did was I extrapolated back to that mixing time and I took the temperature on that extrapolated line, which is right here, inside that lovely square, which I don't want to touch because I got it so good. And you can see that it's at the time 420 seconds, that's fine. But the more important thing is it's 15.8 degrees C. So I'm going to make a text box pointing right here. It's going to say final temperature 15.8 C. And that is your final temperature. And it's actually not pointing to the place on the line, but pointing to the center of this square. But I can't get the software to do that, so we just have to know that. Okay, so 15.8 is your T final.
Okay, we're up to part 2, determining the molarity of a saturated solution of urea in water.
So the second part of this lab says to take a small beaker, 50 milliliters, I think these are so cute, and to put some of the urea in it, between 4 to 6 grams. So what we're going to do first is to tare it. So I'll re-zero it. Okay, and I'm going to put between 4 and 6 grams. Doesn't matter what it is as long as I know what it is exactly. So try not to spill. I think that's good. So I'm going to close the doors and we'll wait for it to stabilize. So let's say it's 5.1442 grams of urea for part 2. Okay. All right.
Hi. Well, we're about ready to do the second part of this lab, which is to dissolve the urea in water, but to only just dissolve it. In other words, we don't want to add more water than we need to just exactly get to the point where every one of those grains of urea disappears. Okay, so in other words, we're making a saturated solution. And the concentration of the saturated solution is actually the equilibrium constant in molarity units. So, so what we have here is a burette. And I've measured the initial volume as, what was it again? Oh, we wrote it down. It was 19.65 milliliters. That's the initial value of the water. And I have the weighed out urea, the 5.1442 grams in there. Actually, I may have forgotten to flow the water through the tip. So I think I'm gonna do that. And I'll have to retake that initial volume. Sorry about that. So there we go. This happens sometimes in lab.
Cross
you know?
it out.
We're just going to cross it out with a single line, like we are always saying you should do. So that's 20.69. I would say 20.69 is the volume, the initial volume. So it says in the instructions to add, if you added 5 grams of urea, to add half that in milliliters of water. So if I had 19.65, and I add 2, say 2.5 is about half the number of grams, which was about 5. 22.15. So I'm going to let the water flow in here until I get to 22.15. Oops, I have to put the beaker under it. So. Did I do that right? I'm not sure about that. Oh, well. 19.65, 22.
Yeah, that's right.
Except it wasn't 19.65, it was 20.69, remember? We have a lot of fun in lab correcting our mistakes. So it should be 23.
We never make mistakes in lab.
23, but didn't feel like 2.5. All right, there we go. So that's what we did. We added about 2.5, so we're about at 23.19 mils. But we don't care what the value is now. We care what the value is at the end when it's all dissolved. So now I'm going to put the thermometer back in here, because what's going to happen to the temperature as we're doing this experiment? Boy, if the stirrer works, it'll be a miracle. Well, luckily it's not a glass thermometer, so this probe is not going to break.
Let's see what the temperature did.
So, the temperature, whoa, it went down to 12.9.
Oh my gosh, do you believe
It was
that?
up at, wow. Well, I expected it to go down, so I'm not really surprised. But what we have to do is we have to get the temperature back up to 25. The reason is because when you measure this equilibrium constant, it depends on temperature, and we want to get it at the standard temperature, which is 298 Kelvin or 25 degrees C. So I'm going to have to heat this a little, but not for too long. So I'm going to put the heat on 2 and just count to like 3. I'm going to turn it off. Look, it's going up. So I'm just going to be very careful about that. What is that thing?
Don't know.
Just say okay to whatever it says.
Ooh,
It's going up.
what,
It may not going up. It
13.7?
doesn't. Oh, it actually does have some heat on here. So it's off now. So I just put it on for a little bit. And we're going to be very patient about this experiment, because if you end up with a temperature of 40 degrees C, you basically have to do it over, because you don't know what the saturated solution's concentration is at 25 if you end up at 40. So the longer you take to do this experiment, the better it comes out. I know this from experience. The trouble is, this is not.
You might be able to heat it a tad more.
No, feel
No?
it. It's actually warm. It's actually too hot.
Oh wow, it's very warm.
I'm And if it does get a little higher than 25, no problem, because I'm not at the saturation point yet. Actually, I'm going to put some black paper or black cloth so we can see how the dissolving is going. Unfortunately, I got to raise this up a little.
That's going up quite fast.
Well, but that's because I took it out for a minute, so. Oh, you see, now you can really see how cloudy it is.
Oh, that's really good.
And this probe would be nice if it wasn't right on the edge. But the probe is also measuring the temperature probably. If it's flat against the bottom, it's probably measuring the temperature of the heater a little bit. So I'm going to raise it up just a teeny bit. Actually, I think I need to close this.
It's up to 20.
I might have changed a little there because I actually raised it up off the bottom.
That actually didn't go down, it went up.
Good. Well, I'm going to add a little, well, I'm going to wait. I'm going to wait. I told you patience. Everyone's always tempted to add more, but it's just the temperature's going to go down. I'd like it to be maybe a little higher so that when I add the water, it actually goes down to 25. Still plenty cloudy because we haven't added any more liquid. And the temperature is still going up from the heater, but very slowly, nice and controlled. Still a little warm, just a little warm. Still going up, look at that. All right, so as you can see, the temperature is a bit above 25. In fact, it's almost 26. So I'm going to add a little bit of water. And let's see what happens to the temperature. It's too close to the edge. Okay. I only added about 6 drops. You can see it's still way not dissolved. So I'm going to add a bit more. Oops. Added quite a bit there. But it's still lots of solid in there. And you notice the temperature's gone down again. It's a little hard to see, isn't it?
Mm-hmm.
Well, you could see it's cloudy, but man, I
You
could
can't
see
the crystals
I could
like
see
that.
individual crystals. A little bit you can. And the temperature is 22.5, so it's gone down quite a bit. Is there any angle we could get that?
From the top, maybe.
Oh yeah. Oh yeah, look at that. Really see individual crystals. Glad I did that.
Looks like fewer than before.
Yeah. Oh, thank you. All right. Is it going up? It's going, it went down. Did it go up at all? I don't know.
I don't
I
think
wasn't
so.
looking at it.
I don't think so.
And the heater does feel a little warm when I touch it with my hand.
Okay, there it is, went up 1/10 of a degree.
So I put a little tiny bit of heat on, but then shut it off. But it feels a little warm. And like I said, the key to this is to do it slowly. So I'm going to be patient. It's still going up. I've had students end up with 50 degrees at the end of this experiment. I've had
Wow.
students end up with 26 degrees or even 24 or 5. That's really good. If I
Yeah.
end up with between 23 and 27, I'll feel like it's a victory. I think I'm going to shoot it with a little bit more heat. We're on low. 1, 2, 3, 4, 5, 6. Turn it off. It should go up a little faster now, I hope. And still, you can see a lot of crystals. Broken 23, all right. I know this might be a little more interesting. Not that interesting though, I gotta say. 10 for 25, slowly. Still feels warm though. I think it'll break 25. Still feels warmer than room temperature. So.
Oh, it's still going up.
When it reaches 27, I think I'll add some more water. If I can wait that long. Maybe I'll put just a few drops.
Put something in there.
Yeah. When it, oops. Not that easy to see, I gotta tell you. Well, I can't even tell, it's so close to the edge.
Yeah, I see drops.
But there's plenty of crystals still in there. Let's see what happens to that temperature. It's going down already. But you know there's fewer crystals in there by a little. Let me show the picture.
Just hold it down a little bit.
Yeah, I know, that's what you have to do.
Quite a
You
few
could
left.
see, oh, look at that. It's less, but it's still quite a few. And now the temperature is going down from the dissolution. So what does that make the sign of the delta H as the temperature is going down? Of course, now I have the heat on as well. I mean, I had it on, so it's still warm, so it's gonna start coming back up. Looks like it's like right at the balance point. It's not doing anything. Whoa, it's really very, many fewer crystals in there.
Mm-hmm. It's going up.
Because of the heat. Maybe I'll put in another couple of drops
I
in.
think you might want to add a few more drops.
I really can't see it.
I can see a few crystals. Not a lot though.
I added 3 drops. Wow. I think we're almost at the end, if not at the end.
Yeah.
And look, the temperature is 25.9.
That's good.
Are there any crystals in there at all? No shit.
I don't see them from here. No, I don't see any more. Don't see them.
Look at it, looks so much, it's very clear. It's a little hard to see with the camera, but let's shut that stirrer off for a few seconds. Look at that, nice and clear. And I can't be more than 3 drops off, because that's all I added that last time.
Wow. So if you jumped the gun and added too much, you'd be out of luck.
And the temperature is 25.9. And let's measure the volume here. Piece of paper, please.
Oh.
Let's see. It's about 25.8, but let me see if I can get, I'd say, you know, I'm gonna move this just a little. I'd say it's 25.80. All right, so we have our data. We can figure out how much water was added.
Convert the milliliters to liters. Convert the grams of urea to moles and find the molarity. That's it. That's going to be the equilibrium constant.
So I think that box, wait a minute. I've got 2 boxes. I gotta get rid of this one. Oh, I gotta shut it off. And then I'm gonna hold it over, if I can move it. Uh-oh, what happened?
So there was an initial drop because of the dissolution, but then the temperature is going up to room temperature because room temperature is higher.
Oh no, battery level low.
All right, girl.
Okay, so what I'm
Wait,
going...
wait, it's on, it's close up. I don't want that.
What?
I cut you off.
So what I'm going to do is measure the initial value. 19. All right, just turn it off.
It's just... Well, luckily it's not a glass thermometer, so this probe is not going to break. We'll just have a piece of dirt in there.
Yeah, that's not bad.
I have to get that dirt out. I really don't like that.
It's like a bug.
Is that a bug? We'll just leave the bug. It's not going to
Leave
affect
the
the
bug.
solubility.
Leave the bug. Not going to cause any problems. Let's see what the temperature did.
So,
Tad more?
no, feel
No?
it. It's actually warm. It's actually too hot.
Oh wow, it's very warm.
This is going to go above.
See, I burn food sometimes on my
Show
stove.
them
So.
this. So, you can't see much. It's just stirring, but
Can you
it's a
feel the
little
heat
bit-
on
a
that?
little- Yeah, can you feel the heat?
This is feel-o-vision.
Yeah. So how many more of these labs do we have to do, Mrs. Saya? We
Oh,
have 2 more.
I
That
think
means
2.
We've done like 10 of them.
that means we're going to get more silly. No, folks, we didn't have anything special
Hey,
for breakfast.
And if it does get a little higher than 25, no problem, because I'm not at the saturation point yet. That bug is not dissolved yet. All right, I think I'm gonna add them. I can't wait. I'm worse than they
Let's
are.
do some calculations or something, you know.